Hey, all you cool cats and kittens. Let's talk about SI prefixes and scientific notation and converting between different prefixes because I think there was still some confusion in the room today. So, the whole point of scientific notation and prefixes are to make dealing with big numbers or tiny numbers more convenient. So let's say we have this number right here. Thousands, million, 314 billion, 159,000. It's cumbersome to have to write down all the numbers if you're doing calculations or recording anything or reading this number off of an instrument. And so one step to make that less painful is that you can use scientific notation, which is just realizing that if we take the decimal, which would be here, and move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places over here. 1, 4, 1, 5, 9. What we really did when we moved the decimal was 3, 1, 4, 1, 5, 9, 0, 0, 0, 0, 0, 0. That's the original number. We divided by 10 to the sum power. And the number of zeros that we divided by is really here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We divided by 10 to the 11. That's how we moved the decimal. That's what you're really doing when you move the decimal. And since let me see if this works. Yeah, there we go. Since I divided by 10 to the 11, if I just stop and say, okay, here's my new number, what's the problem? Well, obviously this number that I wrote down is vastly different from the number that I started with. And so the goal with scientific notation is to represent the same number. And the way that you can do that is by multiplying by 10 to the 11. Multiply this times 10 to the 11. How does that fix it? Well, when I moved the decimal, what I really did was divide by 10 to the 11. And now if I multiply by 10 to the 11, I'm not actually changing the value of the number. It's just the same number. So 3.14159 times 10 to the 11, that's the same number that I started with. It's just more convenient to write now. And the general rule is that this number in the front before the times 10 to the part should be between 1 and 10, or before 10. If the goal is to represent numbers in a more legible, understandable way, the rule that people try to stick to is to have this number be somewhere between 1 and 10. Because if you're moving the decimal around and dividing by 10 and multiplying by 10, why not do it so that you end up with a reasonable number out in front? That is not to say, though, that you always have to have a number between 1 and 10 in the front right here. If you have some other reason why it would be convenient to have it be, let's say, 31.4159 times 10 to the, it's not 11 anymore, because I only moved here. If I'm stopping at 31, that would be like only moving it not 10 places, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it would be moving it 10 places, not 11 places. So now I really am dividing by 10 to the 10, and I should multiply by 10 to the 10. So this should not be 10 to the 11, it should be 10 to the 10. But I don't like to think about the decimal that much when I'm dealing with scientific notation and when I'm converting one number to look like a different power of 10. Like if I want to rewrite this number so that the power of 10 that I'm using is 6, I don't want to have to redo everything that I just did and think about counting how many spaces I moved the decimal, dividing by that number, multiplying by that number. It's just a lot to do for simply rewriting the number. What I do instead is just think about how much I've changed this times 10 to the part, times 10 to the 10 part by, like how much did it change by? It changed by 10 to the 4. This new power of 10 is 10 to the 4 smaller than it used to be. So if I want to guarantee that I'm not actually changing the value of this number, then the other part of the number before the multiplication sign, it needs to be 10 to the 4, a factor of 10 to the 4 bigger, which really corresponds to moving the decimal so that it's a bigger number. So 3, 1, and then 4, 1, 5, 9. So 1, 2, 3, 4. Yeah, I moved the decimal 4 places. It's like multiplying this by 10 to the 4. Since I divided that thing by 10 to the 4 and I multiplied that thing by 10 to the 4, I get the same answer, right? So this number is the same as that number over there. I mean, the whole thing, not just the first part. These two numbers are equivalent. They just have different powers of 10. And the reason that's useful is because now that we're dealing with some SI prefixes, you may have a number that would be very conveniently represented by one of these prefixes if only you changed what power of 10 you were using to write it. So like if I had 4.7 times 10 to the 13, and this is some giant distance that we're talking about, meters. 4.7 times 10 to the 13 meters. It would be nice if I could use an SI prefix to even further simplify how to talk about this number. And the way that you would do that is go look on this table of prefixes and see, is there one that has a power of 10 to the 13? And you will realize that there is a 10 to the 12 and a 10 to the 15, but there's not a 10 to the 13. So how are you going to use a prefix to represent this number? You pick which prefix you want to use, whichever one is more convenient. To me, it looks here like tera might be the most convenient prefix to use. So in order to use tera as the prefix to write this number, I first have to change the number so that it's written with times 10 to the 12. Well, right now it's times 10 to the 13. That is 1 power of 10 smaller. So this part of the number needs to get 1 power of 10 bigger to balance out that change. And if you think about it like that, I think it's fast. I think it lets you change these numbers quickly and be sure that you didn't alter the value of the number. I'm not saying you have to think about it that way. That's just how I do it, and it works. So 4.7, oh, what's it doing? Let me erase that. No, hold on. I'm struggling. The battery in my pen died, and I'm using a tablet that I'm not used to. Meters. There we go. 4.7 times 10 to the 13 meters is the exact same measurement as 47 times 10 to the 12 meters. Now, though, what I can do is realize that 10 to the 12 is a prefix, or I knew it was a prefix ahead of time, and so I can just replace the times 10 to the 12 part with tera meters, and 47 terameters is this number, is this number. They're all the same number. It's just that now it's really easy to say it and write it, 47 terameters. That was, I think, maybe one of the big points of confusion for what we were doing today when we were playing with switching out prefixes and whatnot. Feel free to keep asking questions if something doesn't make sense.